Okay, so let's go for just give me a moment. Okay, so let's have a discussion on stateful set in Kubernetes. Okay, let me share my screen. Okay, able to see my screen? Okay, just a moment. Abdullah is not joined. Just a moment. Abdullah is joined, right? No? Okay. Okay, so let's have a discussion on, is my screen visible? Visible to everyone?
It's visible. Yeah.
Okay. Okay. Right. So let's have a discussion on stateful set. Okay. So let's write statement for stateful set. So stateful set is basically, okay. So stateful set in Kubernetes, it is a kind of controller. Okay, so controller that manages the deployments and scaling of the pods. Okay, and with a unique name. Unique name in the sense, unique name, unique identities, and stable storage. So say suppose when we have a stateful applications of DBs, right? So when we are handling huge data, okay, that should be created, deployed, and scales with a unique name. Say suppose when we are in a Kubernetes environment, we should be created with the say suppose if you are interacting with MySQL database or Postgres database, okay, so those database to be created in terms of pods, right? So when you are dealing with database, say suppose if you want to create MySQL pods, which is handling the data, which is handled data in terms of pod. Your SQL database. Okay, so that is the case. We do prefer stateful set applications. Stateful set applications when we are saying that when we are dealing with the databases, like Postgres and the SQL. Okay, so I'll give a definition here. You understood this statement for stateful set? See, basically it controls and manages the deployment and scaling of a pod with unique name. Unique name in the sense, say suppose if you want to create 4 to 5 pods of MySQL database pods, it will create MySQL 1. So it will create this way. Okay, starts from the 0, MySQL 1, then MySQL 2, and MySQL 3. So the stateful sets will create a pods like this. Suppose if you are using Postgres, MySQL. Okay. Suppose if you are using Postgres, if you want to deploy, if you want to create, if you want to deploy multiple pods of the database, it creates Postgres 1, Postgres. It starts from 0. Okay, so 0 and 1. So that's how it creates. So called stateful set means the stateful set is a Kubernetes controller that manages, means this way, this kind of unique name, unique identities, and the stable storage means, so when we are handling a huge data in databases, we should be handled with the stable storage. We should not lose the data, correct? So when we are dealing with the database, it should be stable. Say suppose it's complete 4 pods of MySQL or these 2 pods of Postgres, we should be handled with the stable storage. That is the case, we do prefer stateful set. Clear with this statement?
Yes.
Okay. Now I'll give a definition here. Okay, stateful set. Stateful set is a Kubernetes controller that manages the deployment and scaling of a pod, pods with unique name, unique identities, stable storage. Okay, so this we call it as stateful set. Example are below. Okay, so you can refer these, means there are multiple pods of, so when we are dealing with stateful applications in databases, you can say an example this way. Okay, you can say an example for MySQL or Postgres of stateful applications. For stable storage for stateful applications. Okay, so this is how we define the stateful set. Okay, now we see when we are discussing about the stateful set, so you might think on the deployment, correct? See, we can also do it from deployment, correct? Instead of preferring with stateful set, correct, right? Now, what is the difference between deployment versus stateful set? This we can achieve through deployment also, right? It can also create instances of a pod. Here we are creating instances, right? Now let's learn about the difference between deployment and the stateful set. Okay, because we need to understand if there are any multiple concepts that we are discussing in Kubernetes, we just need to compare and we need to keep in mind. Okay, difference between deployment versus stateful set, right? Now, see, we know that deployment, this defines the instances of a pod. Correct? Correct, right? See, this is basically the instances of a pod, which is modify and create, right? And identical and replaceable. Okay, and these are all identical and replaceable, correct, right? In case of stateful set, okay, so in case of stateful set, it gives the each pod in a unique name, stable network, identity, and persistent storage, even if it's restarted or rescheduled. That's why we prefer the stateful set. Okay, so when we want to maintain the unique network, when we're handling the huge applications, huge amount of data in a project, the large scale projects, we prefer stateful set so that we can have a stable network, right? So when we're handling databases of MySQL and Postgres database, we do prefer stateful set. Okay, that is the case. We can have a stable network, unique name, stable network, persistent storage. Unique name in the sense the series of order-wise pods for MySQL and series of order-wise for Postgres. Even even when we are deploying this kind of deployment, so the data might or network might change, right, when we deploy it. But we will get a unique names and the order-wise. But we want the actual data which is handled by these pods. That is the case. We do prefer stateful set. Okay. So I'll give a definition here. So it gives each pod in a unique name, stable network, identity, and persistent storage. Okay, even if the benefit restarted. Even if it restarted or rescheduled. Okay, so that is the case. So we do have a comparison between the deployment and the stateful set. So we should want the stable network. See, you can have a discussion in the team or in the project when they are going to deploy in the project. You can refer both, either we go for deployment or stateful set. But keep in mind, when you are having the stateful applications in the sense your MySQL, your Postgres, your Kafka. Anybody heard about Kafka here? Or Zookeeper? Or the distributed systems, we call it as Kafka and Zookeeper, where they're handling huge logs, huge data. Those kind of configuration, we do prefer stateful set. Okay, so we were using Postgres database and we used to have a multiple pods and we preferred with the stateful set. Okay, you getting my point now? Okay. Now, so when do we use the stateful set, right? So I already explained stateful set used for stateful applications, correct? So I'll give a definition. Stateful set used for stateful applications. See, you need to remember this always, okay? And don't get confused with stateful set in the deployment with the demand set, okay? So what are all those stateful applications? Kind of databases, okay? Okay, so what kind of databases that we prefer in the project or maybe in the market? MySQL, right? And Postgres and MongoDB, right?
Yeah.
So those kind of databases we prefer when you are dealing with MySQL, Postgres, MongoDB are the stateful applications kind of databases. Similarly, when we have the distributed systems. So what kind of distributed systems that we have? Kafka, right? And Zookeeper. Okay, so these we call it as distributed systems where we want to handle huge data, right? So that is the case we prefer stateful set. Okay, now now these applications that require a stable unique pod name, like as I said, see, suppose if you want to configure MySQL database and that should handle that require the stable and the unique pod name this way. Okay, so we do create the stateful set 0 and it starts from 0, 1, 2, 3. Okay, and also ordered deployment, and even when it terminates, when terminating only it also follow the same order. Okay, you getting my point? Suppose if you want to delete, it will delete with 0, then it will go to 1, then it will go to 2, then it will go to 3 when the pods are getting terminated. Okay, so I'll give it this way, maybe you can get the complete clarity. Applications that require stable unique pod names like MySQL 0, and similarly, okay, I'll give it this way. 1 and MySQL 2. Okay, so this we call it as applications that require stable unique pod name this way. Okay, suppose if you are in a order of deployment, if we are in a creation of deployment and termination. Okay, in case of termination, it starts, see here also it starts from pod 0, then pod 1, and then pod 2. See what I'm trying to say here. See, when, okay, I'll keep this. Okay, so when the pods are getting created, it will also follow the unique pod name like this. Similarly, when the pods are getting deployed or terminated, it follow the same order. That's it. So called the stateful set. See, it will go and terminate in the middle of pod 1. No, it will go from pod 0, then it will terminate pod 1, then it will terminate pod 2 if the node is getting removed. That's how it follows the ordered wise. Okay, you're getting my point. The ordered. Okay, so if we're in a creation of ordered deployment. Okay, and terminations like pod 0, 1. See, basically The intention here is to create, when it is creating a pods, it follow the ordered, and whenever it is terminating, it follows the ordered way. That's it. That's the reason we do prefer the stateful set. Okay, now let's work on a practical part of stateful set. Let's deploy a simple stateful set. That how do we create, and what is the YAML that contains, how do we write that. Okay, I do have a sample template for stateful set. Before moving to that, let's start an instance. Okay, so basically, so as I said, we're gonna use when we are dealing with the databases. Okay, let's log into this. Okay, followed by, I'm gonna point the key. Okay, now let's do ls. Okay, now I log into server. Let's change settings. Please change. Let's keep it 18. Apply. Okay, here. Okay, now I do have the stateful set YAML here. So when we have the for MySQL database. Okay, so I'm gonna copy this. I'll explain. Okay, so I'm gonna create a file of statefulset.yml. Okay, so pi statefulset.yml. Okay, so I'm gonna point here. Okay, now see the very first line, we do have API version, that is v1, and the kind I have mentioned here is stateful for stateful set applications. Here I'm gonna use MySQL as a stateful application. Okay, under metadata I'm going to define as MySQL. You can also create Postgres for stateful set. See, currently I'm going to create stateful set for MySQL. Okay, under spec I'm going to define service name as MySQL. Instead of that, when you're using Postgres, you can also point your Postgres and your MongoDB. Okay, and the number of replicas that we need here is 3. Okay, so if you want, you can give 5 also. Okay, remember that we also provide the deployments as a replicas in deployments. Correct, here instead of moving it to deployment, we are creating stateful set to maintain stable network, stable storage, and the unique name. See, anyways, we can maintain unique name by doing a deployment, but here we are preferring MySQL as a stateful applications. Also, when you want to deploy your Postgres or MongoDB are the stateful applications, Zookeeper and Kafka, there are a lot of stateful applications. Okay, based on that, you can choose your component from Kubernetes. Okay, and under selectors, so I'm gonna give match label as app MySQL, and selectors, it should point a particular app as MySQL, and under metadata label also I'll keep it as MySQL. Okay, and under spec we need to define the container specification and the mount path. Okay, so where the data should get mounted. Okay, under the container I'm going to give container name as MySQL and the image of MySQL, which is the version 8. This pulls from the remote. Okay, and the container port 3306 of MySQL, and the volume mounts under the volume that we're going to mount it under /var lib MySQL. Okay, inside the container. Okay, and the name MySQL data, the volume data will be MySQL data, and which is mounted under this path in the container. Okay. Now here we do have volume claim templates, right? So under volume claim templates, we do prefer, see, the name of the volume is MySQL data. Here we define under metadata, and under the spec, what is the access mode? See, basically it's a database. We need to access the data, okay? And it should be read write once, means we need to access it. Okay, under resources, we provided that 1 GB. Each pod should create, see, wherever we define resources, we do create CPU on the memory, right? Here we're going to define storage of 1 GB with the read write access. That's it. Under volume claim templates. Okay, to getting my point, this might be looks like new line for you guys, right? So we define volume claim templates. So each pod should create 1 GB of data with the accessible. Okay, clear with this? Okay, if this stateful set is not working, see, it should be always create a write pod. Okay, now I'm gonna save this. You were able to understand this, Yamal?
Yes, sir.
Yes.
What about others? I'm asking with everyone. Rakshita. Rakshita, Amruta, yes.
Yes, sir, Nick, understood.
What about Rakshita?
Yes, sir, I understood.
Okay. Now, what I'll do, I'm gonna deploy this stateful set of MySQL data. Okay. Now, if I do ls, okay. So how to deploy? kubectl apply -f stateful set dot YAML, right? So let's apply this. Shit, I did not configured Minikube. Let's configure Minikube. Install and start the Minikube. Okay, let it start the Kubernetes Minikube. Okay, so okay, and if that stateful is not worked, we can create, we do create a secrets of MySQL, and also we do create a services with the same stateful application. Okay, and also we can learn about the secrets handling in Kubernetes. Okay, I got the question on as a part of doubt, right? So how do we attach the secrets in Kubernetes? Okay, we do create a secrets, okay, for base 64 encoded. Okay, we should follow always base 64 encoded. So how do we, okay, now this Minikube is configured. Okay, now, so I'll just show an example. How do we use base 64? Okay, so say suppose if you want to use any data as an encoded, what I'll do, I'll just show how to use base 64. Okay, see, suppose if you want to create encoded base 64 credentials, the secret, we do prefer here, just you were able to see my screen, right? This is very important. I'm creating a encoded secret for root at the rate of 123 for a secret with base 64. You were able to understand this command?
Yes.
You guys are with me?
Yes, yes.
Okay. So anybody know don't know base 64 here? Rakshita. Base 64 is an application where we encode, we encrypt the password.
Yes, sir.
Okay. Now, if I run this, we will get a unique password secret. So when you point this in your YAML file, it always represents your password as root at the rate of 123. We need to point this in our YAML. Okay, let's see how do we define and how we interact with that. Okay, now this is clear, right? Before running base 64, you should run base 64 version that you installed. Okay, so I have installed with 9.4 version of base 64. Guys, just a minute. Sorry. Yes, here we have configured with minikube. Now let's build the stateful set. Okay, so kubectl apply -f stateful set dot yml. Okay, let's run this. Oh, I did not set the alias. Okay, now let's run stateful set. Oh shit, stateful set. I'll do same mistake always when I'm working also. Stateful set. Okay, now the stateful set of MySQL stateful set apps dot slash MySQL is created. Okay, now how do we get this stateful set? kubectl get stateful set, right? Similarly, you will get whenever you create a daemon set, you will get listed this, and whenever you create affinity and anti-affinity or deployments, you will get a similar command, right? Now we created stateful set. How do we list this? kubectl get stateful set, right? So if I run this, we can see it is created. MySQL stateful set is created of pod 1 of 3, right? Now how can I see the complete output in a void format, right? We should see the 3 pods. Remember that under stateful set, the replicas that we provided as 3, right? We should see 3 pods, right? Now here 1/3, only one is running, correct, right? Now how do we get rest of the 2 pods will get working? See, we should not get 1/3, it should be 3/3, correct? Okay, now remember that we had defined the persistent volume which is attached to that particular stateful set, correct? If I do a cat of stateful set here, see here the volume that we attached here this way. Just a minute, guys. Okay, so now now once we create this, so how this persistent volume, this data of 1 GB will get handled by all the pods. Okay, now to know this persistent volume climb, see here volume climb templates, each pod should contain 1 GB of MySQL, correct? To get that, we're gonna use kubectl get PVC, means persistent persistence volume claim. Okay, now we can see here MySQL data, and the volume status is bound, means that pod is bounded to MySQL, and the volume is created this way, and the capacity of 1 GB. Access mode, read write once, correct? RWO. So what we given here, read write once, correct? And similarly the storage, that is standard. It's the storage class, that is standard. And the volume distributed class, currently it is unset, and the age which is created, so whenever we do create it, it gives the latest, the recent time. Okay, here we can see the capacity of 1 GB. You are able to see this unique data and identical of the MySQL database here. It
Yes, sir.
started from 0 and 1 and 2, and the status, it is saying bound. The pod is bonding to MySQL database. Okay, and the volume of each pod is having this. Okay, PVC means persistent volume claim. Okay, now this is how you can see your stateful set. Okay, and suppose if you want to fix, say suppose if either of those, if I run kubectl get pods -o wide, okay, see there are only one is running, the rest two pods which are in crash loop backoff, correct, right? So let's see what is this crash loop backoff and how do we fix that. Okay, now if I run kubectl get pods, so we can see the pods. See MySQL 0 1 2, it created the ordered way of pods, and one is running, and rest two pods are in crash loop backoff, right? So let's see why this crash loop backoff. So to check the logs, what do we need to do? kubectl describe pod, right? Describe pod MySQL 1. Let's see what is happening here. Now let's directly go to the events. Here it is saying default schedulers successfully assigned, okay. Pulled an image of MySQL 8 is okay. Successfully pulled an image, okay. Container created, container image already present. Back off normal, okay. Kubelet started container MySQL. Kubelet back off starting failed. Container of MySQL pod 1 in MySQL 1 default. Okay, why MySQL 0 is created, and why this MySQL 1 pod is similar image only we use now, MySQL 8, right? Back off image, test the error, kubectl get pods, crash loop back off. Okay, now what we'll do, we'll do add, there might be some volume distributed if this is crashed. So what is the case it might crash? So if you see the volume, so when we assigned volume in a YAML file, it might be missing with the distribution of this volume, the storage, right? Now, so what I'm gonna do here, I'm gonna add on the volumes. If I'm just trying to fix the crash flow backoff, okay? So I'm just enabling it, the storage in the Minikube cluster, okay? So what I'll do, I'm gonna just enable the storage provisioner, okay? Minikube add-ons, enable storage provisioner. There might be an issue with the storage, correct, right? Storage provisioner. Minikube add-ons, enable storage. Okay, now storage provision add-on is enabled. Similarly, Similarly, I'm going to enable default storage class. See, I saw this MySQL default means the pods, some of the pods which are crash looped back off to pick the default storage. See, one is running, rest two are not running means we need to enable the storage, right? See, remember that when we do a stateful set, the ordered placement of pod and ordered placement of volumes distributed in each pod. One is 1/1, rest two are failed means there is a failure in the volumes distribution. That is the reason I'm going to add on the storage provisioner and the default storage class. Okay, from this output only I got to know that there might be a missing default storage class. Okay, so again I'm going to define minikube add-ons enable default storage class. Okay, so I'm gonna enable this. Okay, now this is also default storage class add-on is enabled. So what I'm gonna do here, see, once we enable this storage class, how do we get notified? How do we get this storage class, right? So there is a command in Kubernetes kubectl get sc means storage class. You will see the storage of standard default, right? So here we enabled default one, right? Where it is here, default storage class and the provisioner with this path. Okay, and the volume binding mode immediate. So whenever there is a pod creation or deletion, it should attach add-ons the volume immediately from the storage class. Okay, here the default storage class. Okay, this is the command to check the storage class. Now let's run the same command kubectl get pods. Still, if it is in crash loop backoff, what I'll do, I'll delete the stateful set. Then I redeploy it after adding this, after enabling the storage provisioner and the default storage class. Okay. Now, so I'm going to delete kubectl delete stateful set of MySQL, correct? MySQL. Now this stateful set is deleted. Now I'm gonna redeploy it. Even I'll delete kubectl delete PVC. I'm gonna delete the PVC persistent volume claim also. I'm gonna delete it now. Okay, so this is deleted, and now I'm gonna deploy kubectl apply -f stateful set .yml. Stateful set. Okay, now the stateful set MySQL is created. Okay, now if I run kubectl get stateful set, so we can see 0 of 3, and also kubectl get pods. Still it is in error. Okay, now again I'm gonna pick another pod and I'm gonna describe it. Kubectl describe MySQL. Okay, describe pod MySQL. Back off restarting failed. Container MySQL and pod default. It is failing. Okay, warning. Back off. Already present on machine. Okay, what we'll do now? We do create a secrets with the base 64 encoded secret, and we do call that secret in the pod of MySQL. Maybe it is failing with accessing the data to the MySQL. That's why it is, once this access the data, it will restart, right? Where it is failing when the pod is restarting. Correct, right? We can see here, back of restarting failed container MySQL in pod. Okay. Now I do have the YAML file of secret created and the service for MySQL and the stateful set. See, all three we can create in a single YAML. Okay, let's do that. So what I'll do, kubectl delete. I'll delete complete. Okay, kubectl delete. Kubectl delete stateful set. You guys are with me?
Yes, Sandeep.
Yes, sir.
So I'm just trying to fix this back of error. Kubectl delete stateful set MySQL. Okay, it is deleted. And also okay, let's delete the persistent volume claim also. Delete kubectl delete pvc all. It is deleted. Okay, now if I run kubectl get stateful set, okay, when I run kubectl get pods, okay, now see, I have deleted everything. Let's create a secrets for pod for MySQL database and create a service for MySQL and create a stateful set. Okay, I do have the YAML configuration with all three services. Okay, so here is the secret. I'm going to create it for MySQL create as the secret name. This is how we gonna handle the secrets in Kubernetes. Okay, you should be understandable with carefully. Okay, so this is the service that I'm gonna create for MySQL, and this is the complete stateful set. See, whatever that we deployed, the complete flow here, it creates the stateful set with the secret called here with environment. Okay, with environment, the name of the secret, which is MySQL root password. Correct. So what is the name that I'm gonna create here is MySQL secret with the root password. This is base64 encoded. Okay, you getting my point? And this secret only we're gonna handle it in the secret creation. Okay, clear with this? We are creating a secrets of MySQL database, and that we're gonna creating it as MySQL secret and the type as OPEC. This is a kind of type of secret. You getting my point? See, the OPEC is a generic secret type. Okay, type of secret is OPEC, which is in terms of base64 encoded. Okay, so how this generated, I shown already. Control R root. Here, see, this is, so if your database password is root @123, this is how pipe with base64. If I run this, we will get, correct? This only we added here, this secret. You getting my point?
Yes, sir.
The root secret that we added here and the secret that we're gonna create it as MySQL secret, and this we're gonna call it in the stateful set for a stateful applications to maintain, to access the data simultaneously when it is restarted, right? So see, I'm trying to fix the back of error. Okay, see here what it is saying, back of restarting failed. Okay, we should think on why it is failed. Right now, if it is failing with, when we have the stateful applications, it is always access the data of MySQL. The pod will always access the data of MySQL. If it is failing, back off, if it is restarting, once the data picked from the pod, it will get restarted. It will get refreshed. When it is failing with refreshed, there might be some issue with the data accessing, correct? That is the reason we do hard coding. Instead of hard coding, we do create a secrets of MySQL this way. And this we're gonna call it in the stateful set application, the secrets handling in Kubernetes. Okay, so the secret, we're gonna call it as MySQL secret and the root password. Okay, so I'll go to the stateful set YAML. Under environments here, I'm gonna call name MySQL root password and the value from secret key reference. Secret key ref. Secret key ref means the very first component of our complete stateful set YAML is secret creation. This picks that represents the environment represents pick the secret from this MySQL secret reference, secret key reference, right? And the name of the secret is MySQL secret, and the key should be root password, which is base 64 encoded here. So that through this, the pod can access the data from the MySQL database. Getting my point? And we can also create a service for MySQL. Okay, it's better to create a service because we will be having the connectivity, right? So once we create a pod, there might be a IP get changed when the pod is deployed. But in case of service, we'll get a stable IP, right? That is the reason we do prefer the service creation, correct? Correct, right?
Yes, sir.
That is the reason we do create a services here at the K8S service, and under metadata, the name of the service is MySQL and the port for MySQL 3306, and the cluster IP I have kept it as none, and the selector and the label that I have pointed here is MySQL. It should create a service for MySQL. That's it. And when we start the stateful set, so everything is same, that the one we deployed, which we got a back of error. The service name as MySQL, replicas 3, and the only difference, the new component, the new parameter that we added here is environment. We are going to call the password secrets into the YAML file, into the stateful set, which is this. Okay, and the volume mounts, everything is same, and the volume climb templates is same. Getting my point?
Yes, Sandeep.
You guys are with me?
Yes.
Yes, sir.
Everyone slept or left the session here?
No, sir.
No, sir.
Hello.
Yes.
Yes, sir. You're audible.
Is this clear? See, directly I'm discussing here to create the secrets and handling the secrets and the service creation and the stateful set creation in a single YAML. Okay, this we also do it from the Helm charts. Getting my point? Okay, so what I'll do, I'll copy this and I'm gonna replace that with a new YAML because of that image pullback of. Okay, so okay, instead of deleting stateful set, okay, I'll delete. Okay, MySQL. See, and the very first component, it creates the secret in Kubernetes, and the second component creates the services of MySQL here, and the third component creates the stateful set for MySQL, and under environment, we're gonna call the secret. We are handling the secrets here this way to access the MySQL database, which we created in Kubernetes, and the volume mounts and the volume climb templates which distributes the read-write access. With the each pod should have the 1 GB of data. Okay, I'm gonna save this. Okay, so I deleted everything, and again I'm gonna redeploy it. Okay, kubectl apply -f stateful set .yml. Okay, so I'm gonna secrets unchanged means it is unchanged. I mean, if we ran previously the same secret and service, it will show unchanged. Okay, so even stateful set is created. Right now let's list kubectl get stateful set. Correct. Now is it showing 3 out of 3? Did we fix the stateful backup error? So when we run kubectl get pods, all 3 pods are running now. Did we see the backup error?
No.
And we fixed via the accessing the data. That's why it was showing the data which is accessing here. See here what it is saying, back of restarting. You should think on back of restarting means if your pod is accessing the MySQL data, it will get restarted. Means there might be an authentication issue. Right? Correct, right? And also you can see here some of the warnings. Failed scheduling, default scheduler, notes are available, pod has unbound immediate persistent volume claims, preemptions of 0 out of 5, notes are available, preemption is not helpful for the scheduling. See, there might be an accessing the data when it restarted. That's why we are getting a backup error. Okay, now that is fixed with the secrets that we created, and we handled that secret in the YAML file in the stateful set. Now we are ready with the stateful set of all 3 pods of MySQL. Getting my point now? You getting it? So that's how we do fix the backup error that based on your applications that you are dealing. Okay, now let's list all the kubectl get stateful set -o wide. So this gives the stateful set complete image which we pointed, and the containers of SQL which is picking, and the ready state. Right now, before it was 1 of 3. Right, 1 was failed and the rest 2 are getting failed. Right now all 3 pods of stateful set pods are running. Right now, how do we see this persistent volume climb? kubectl get pvc. Correct, it's persistent. Now we can see bound, and the name of the pod is this pvc, the persistent volume climb. And also, see, we can see here, right, even kubectl get pods. Right, so all 3 are running now. Now when we want to kubectl describe, is the stateful set MySQL pods, sorry, kubectl describe stateful set of MySQL. Now everything is cleaned. Right, create pod of MySQL 0, MySQL 1, MySQL 2. This is it created stateful set controller from the stateful set controller. Right, you can see the logs here, right, the events. Correct, and the access mode that we pointed in YAML, read write once. Through this it will be keep on accessing the data, and it will get restarted whenever there is a new entry in the MySQL, the new schema or tables which get added. It access the data, picks it, and that is handling with the pod, via the pod. Clear? Clear with this?
Yes, sir.
Anybody has any
Sandeep.
questions?
Yes, sir.
Okay. So what I'll do, I'm gonna share both the ML file. So if you're deployed with the stateful set with a single YAML file, then fine. If not, you can refer with the below one. Okay. So what I'll do, I'm gonna run history first. Then anybody has any questions, guys? Anything that you want to understand? History.
Sandeep, in
See,
the real time, so now that in the back end of SQL, developers should share the credentials, right? So how do they share, like through the AWS secret manager, or like how do they share the secrets file, basically?
see, secrets. See, when we are handling secrets via the Kubernetes YAML, we do pass this way. Suppose if the secrets are, there is a provision to give it from the cloud, we do prefer the cloud secrets. See, there might be encoded base 64 wherever you
No,
use.
I am asking about like now that backend is secrets should be given by the developers, right? Because they need to set
Yeah,
the
yeah, yeah,
database.
yeah. Correct,
So how do
exactly.
they share to us, like as it for the DevOps engineer? Like, do they encrypt and share? Like, how do they share
No,
that?
no,
I
no, no.
want to
If
know.
they encrypt, see, always they'll share this password only with the privately.
Okay.
Okay. So they'll not give any encrypted password. This we need to encrypt using base64. We want the actual password to encrypt it, right?
Yes, yes,
So
yes.
earlier only when encrypted by developer, how do we encrypt it, right? So
Yeah.
we want the actual password, then we do encrypt using base64.
Okay. Do they put in any AWS secret manager, or directly
Yeah,
they do share?
they will keep it in AWS Secret Manager. Even
Okay.
similarly for Azure.
Okay, Sandeep. Thanks.
Okay. And again, anybody has any doubts, guys? See, you were able to understand when I share this in the group, right? Commands. You can match the commands, right? So I say for uh, stateful class, storage class, sorry.
Storage class.
Yeah. Storage class. Okay. And also PVC persistent volume client. Okay. Persistence volume client. So you can refer these commands, right? You are able to refer these commands, right? And this I use to provision the storage provision and the default storage class. Okay? And try to deploy this simple single stateful set. If you found the image backoff, you go with this. Means basically we have fixed it via the secrets handling. That's it. With the base 64 encoded. Clear with this? Again, anybody has any questions, guys?
No, sir.
Clear? And did I cover the secrets handling and the daemon set I covered? And EKS, I'm going to explain will deploy an EKS. Okay, it is EKS ingress controller. It is asked by Jairam. You were able to deploy your ingress. I saw your assignment. EKS ingress controller you deployed, right?
Yes, sir, it
You
was.
understood that?
Yes, sir, understood.
Can I remove this?
Yes.
Okay. Now the question is asked by how do we attach the secrets in Kubernetes? Might be Rohit, right? Okay. If anybody
Yes.
asks this, okay. Are you understood this secrets handling here? The secrets that we
Yes, sir.
created and we use the base 64 encoded and we gonna call that in a YAML file. Clear?
Yes.
Do I need to keep this or do I need to remove?
Not required.
Okay. And the rest of pipeline from checkout lane sonar. Okay. Jenkins Docker and okay, volume attached in different container, okay, build failures in captured, okay. So I'm going, okay, daemon set is covered, right?
Yes.
Okay. And config map. I'm gonna take the sessions on config map. Config map. I'll have to. Anybody has to go to office? Let's wind up the session. Then we'll connect tomorrow. Don't be in a hurry when covering our topics. Let's have a time and let's understand more and try to fix the errors and debug, fix the errors. Let's work on it. Okay. Now I'm gonna cover config maps. Okay. And after that, I'm gonna deploy some of the templates from Terraform to create EKs. We'll connect to that. We'll deploy on applications, and I'm gonna show a simple pipeline to check out the lint. And SonarQube configuration is the free trial will not happen. So once we close your sessions, we're gonna plan for a visit to our premises so that we can show the SonarQube configuration. Okay, guys, you need to prepare well. You are still in very low. Okay, we have covered a lot of concepts and you are not up to that interview standards. You are not up to the industry standards, to be frank. Pooja HB, Siddesh, Umar Sharif, and there are more candidates than Rakshita. You need to prepare well here. There are a lot of concepts that we covered. You are still in hiccups. Okay, so we need to start your placements. And again, I'm saying, if you are not capable to get a job here, see, we are not here to get a job. Once you learned, once you understood only, we go for a placement. And if anybody has an thinking of, okay, we joined here and we'll get a job, no, it's not like that. If you learned only, you will get. Our intention here is to, when you join the organization, you need to work independently, right? Why do we need to cover all these, right? We can say just 1 or 2 sessions, we can wind up the Kubernetes, no? We can get a job for you, right? You should not do that. When you are training a tool or when we are guiding with the concepts, we should be satisfied that the candidate is working. Okay. So any questions, guys? Do we need Q&A in the evening for everyone?
Yes, we need.
Yes, sir.
Sandeep,
Okay.
the way you ask questions will help us, so we require.
Okay, fine then. Then you guys should be prepared. And I see that there are a few candidates are not prepared yet. I don't know what is happening with them. You need to prepare well. Okay, let's discuss more topics on tomorrow's session. And I'm gonna complete in another 2 weeks. I'm gonna complete all the concepts from Terraform, Kubernetes, and one flow of CI/CD. And I'll try to show the monitoring also. I'm gonna deploy it, and let's deploy the EKS cluster from AWS, and we'll see that. Okay, so that you will get captured with end-to-end monitoring from the templates, Terraform template, and you will get the way of understanding. Okay, fine. Then let's connect tomorrow. I'll stop. Rakshit is already left. I'll stop sharing the screen. Okay. Let's wind up the session. Let's connect tomorrow. Arun, any questions here? Arun. Okay, let's connect tomorrow. Thank you. Bye-bye.
Okay, thank you, sir.
Okay, sir. Thank you.